Okay, this video will look at question 15, which says, which point on the line y equals 2x is closest to 4, 0? So let's sketch this problem out to kind of get a sense of what's going on and what they're asking for. So you have y equals 2x, which is a linear equation. We know that it's a line because the highest exponent for either variable is 1. So, and the y-intercept is 0. This is y equals 2x plus 0. So here is 0. Slope is 2, so up 2 over 1. And then the order pair 4, 0, 1, 2, 3, 4. So they say which point on the line is the closest distance to the point. So a concept that you'll learn in geometry is this. The point that's going to be the closest on the line will be found on what's called the perpendicular bisector. So let me move this line. All right, so perpendicular means that it forms, two lines form 90-degree angles. Really for 90-degree angles, it's sufficient to just put one box though. So, so we need to find this point right here. So then what do? We need to write the equation of that line. So it's going to be the equation of this line that's perpendicular to y equals 2x. If two lines are perpendicular to one another, that means that the slopes are opposite signs and then reciprocal. So we're going to take 2 or 2 over 1 and make it negative 1/2. Now, we need the line for this, the equation for this orange line to go through this point 4, 0. So we're going to use 4, 0 and then the slope of negative 1/2. So, okay, so my microphone battery died, so I'm going to have to narrate over what I was doing. So you're going to use the point slope form of an equation. You can use the slope intercept form as well. I just personally prefer this one. Slope intercept is the y equals mx plus b. So the goal is to write the equation that has the slope of negative 1/2 and it goes through the order pair 4, 0. So I'm substituting out the x1, x sub 1 and y sub 1 as well as the slope, and then I solve the equation for y by distributing negative 1/2 times x, negative 1/2 times negative 4. All right, so the equation y equals negative 1/2 x plus 2, that's the equation for the orange line, and then you have the given equation y equals 2x. So at this point you have two equations which are a system of equations. We're trying to find that point of intersection. So I'm going to solve these two equations as a system, and since y is by itself for both equations, or at least one equation, we should use substitution. All right, so this is me using substitution. I'm taking y from that equation that's inside the box, replacing it with 2x, and then equals negative 1/2 x plus 2. Want to get rid of the fractions, so I multiplied by 4. Really, multiplying by 2 is sufficient. Yeah, I shouldn't have used 4. So we get rid of the fractions, and then now we move the variables over to one side, so the 2x gets added to the left and right sides to get 10x equals 8. At this point I made a mistake. I actually switched it around, so I have 10 over 8. It should be 8 over 10. So let me pause the video and then speed up to the point in which I made a correction. All right, So what you're looking at here are both equations. The original y equals 2x, and then the new equation we created, y equals negative a half x plus 2. And the answer for that system of equations on the previous slide was 0.80 or 0.8 and then 1.6. So you figure out the x value or y value first, and then you go back to the original equation to determine the point of intersection, and then you're done.